To download the dataset for today's project, open your browser and search for Sentiment Analysis Dataset Kaggle. If you scroll down a bit, you will find Social Media Sentiment Analysis Dataset. Once the page is opened, click on Download and then download dataset as zip. When the zip file has been downloaded, you will find a dataset, Sentiment Dataset Excel file. Extract the file and then open it. As you can see, the file has opened. We have sentiments, hour, day, month, country, likes, retweets, hashtag. Hey everyone, welcome back to the channel. Today we are going to walk through an end-to-end sentiment analysis project using Python. We'll explore data, do some feature engineering, train multiple ML models, and compare their performance. Step 1. Import libraries. For data handling, import Pandas as PD, import NumPy as NP. These are the basic data libraries. Pandas help in reading and analyzing tabular data like CSVs, and NumPy is used for numerical operations. For visualizations, import matplotlib.pyplot as PLT, import cbond as SNS. From WordCloud, import WordCloud. From collections, import counter. These are for data visualizations. Matplotlib and cbond make charts. WordCloud is used to visualize frequent data words as beautiful clouds. Counter counts the frequency of words or items. For text processing, import RE, import string from sklearn.model selection, import train test plate from sklearn.feature extraction dot text, import counter count vectorizer and TF-IDF Vectorization. For text cleaning and preprocessing, RE refers to the regular expression for removing unwanted characters. Train test plate splits our data into training and testing set. TF-ID Vectorizer converts text into numerical forms using TF-IDF term frequency inverse document frequency. Now we will import the models. From sklearn.linear model, import logistic regression. From sklearn.naibias, import multinomial NB. From sklearn.svm, import linear SVC. From sklearn.assemble, import random forest classifier. These are our machine learning models: logistic regression, naive Bayes, support vector machine, SVM, and random forest. We will train all of these and compare their performance. For evaluation, from sklearn.metrics, import accuracy score, confusion matrix, classification report, import job lift. For model evaluation and saving, accuracy score tells how accurate our model is, classification report gives precision, recall F1 score, and joblib is used to save trained models. To ignore warnings, import warnings, warnings.filter warnings ignore. Plot setting sns.set theme style equals to white grid. plt.rc parameters figure size equal to 8,5. We'll ignore unwanted warnings and make plots look cleaner using Seaborn styling. Step 2. Load the dataset. df equals to pd.read.csv sentiment dataset.csv df.head loads the sentiment dataset from a CSV file into a data frame called df. df.head shows the first few rows to check if it loaded correctly. Step 3 is initial data inspection. Print data set information df.info displays info about each column, data types, number of non-null values and memory uses. Print missing values. Print df.isNull_sum checks for missing or null values in each column. Print numerical summary. Print df.describe gives summary statistics like mean, max for numerical columns. Print sentiment classes. Print df sentiment.value counts shows how many samples there are for each sentiment level, positive, negative, etc. Step 4 is exploratory data analysis ADA. Sentiment distribution. Top sentiments equal to df sentiments dot value counts dot n largest 10 dot index. Df top equals to df sentiment is in top sentiments. PLT dot figure size 8,4 SNS dot count plot data equals to df top x equals to sentiment palette equals to cool warm and order equals to top sentiments. PLT.title top 10 sentiment distribution, PLT.xticks rotation 45, PLT.show shows how many samples each top sentiment has, useful for understanding data balance. Platform wise sentiment SNS dot count plot data equals to df top x equals to platform HUE equals to sentiment and palette equals to set 2 visualizes how sentiments varies across platforms like Twitter, Facebook, etc. Country-wise sentiment. sns.countplot.df data equals to df top x equals to country, HUE equals to sentiment, and palette equals to magma. Compares the sentiment distribution across countries. Likes versus retweets. sns.scatterplot data equals to df top x equals to likes, y equals to retweets, HU equals to sentiment. Shows if popular retweets or tweets most like retweets have any sentiment pattern. Sentiment trend by hour. sns.countplot data equals to df top x equals to hour, HV equals to sentiment, and palette equals to cool. Analyzes at what time of the day people post positive or negative comments. Step 5 is text cleaning and preprocessing. Import NLTK from nltk.corps. Import stopwords nltk.download stopwords. Stopwords equals to set stopwords dot words English. Downloads common English stopwords like is, the, and, which don't add much meaning. Def clean text equals to str lower makes lowercase, removes the URLs, remove mentions, remove hashtags, and converts to lowercase. This function helps in cleaning the text step by step. Df clean text equals to df text dot apply clean text. Df text comma clean text dot head 10 applies the cleaning function to every row, creates a new column clean text. Step 6 is text analysis, word count by sentiment. Df top word count equals to df top clean text dot apply lambda x length x dot split sns dot box plot data equals to df top x equals to sentiment and y equals to word count. Checks average word count per sentiment. Longer text may indicate stronger emotions. Most common words per sentiment. Def most common words sentiment n equals to 5 words dot join df top sentiment equals to sentiment clean text dot split common equals to counter words dot most common return pd dot data frame common columns equal to word comma frequency finds the top 5 most used words for each sentiments. WordCloud Visualization. WC equals to WordCloud generate text plt dot im show wc creates a colorful cloud of most used words for each sentiment. Step 7 is feature extraction. Counts equal to df sentiments dot value counts. Rare classes equals to counts less than 2 dot index. Df sentiment equals to df sentiment dot replace rare classes comma other. Combines rare sentiment labels into one group called other. TF-ID equals to TF-ID vectorize max features equals to 15,000 x equals to td dot fit transform clean text y equals to df sentiment converts all text into TF-IDF vectors, a numerical form for machine learning. Train test split x train x test y test equals to train test split x comma y test size equals to 0.2 and random stat is 42 and stratify equals to y splits the data into 80% training and 20% testing while keeping the sentiment ratio the same. Step 8, Model Training and Comparison. Models equals to logistic regression max iter equals to 200, naive Bayes, multinomial NB, linear SVM, linear SVC, random forest classifier, n estimators equals to 200, random state equals to 42. We define four models to test. For name model in models.item, model.fit, print f name accuracy equals to ACC4f. Loops through each model, trains it, tests it, and prints its accuracy. Step 9, Model Accuracy Visualization. sns.brplot x equal to list result.keys y list result.values plots a bar chart to visually compare accuracies of all models. Best model name equals to max results key equals to result.get finds the best model with the highest accuracy. Step 10 is evaluation of the best model. Best model equals to models, best model name, y predict best equals to best model dot predict x test, print classification report, y test, y predict best. Prints a detailed classification report, includes precision, recall, F1 score for each sentiment. Step 11. Save model and vectorize. Joblib.dump best model best sentiment.model.pkl. Joblib.dump TF-IDF, TF-IDF vectorizer.pkl saves both the trained and the TF-IDF vectorizer so you can use them later without retraining. Step 12. Predict sentiment on new text. Def sentiment predict sentiment text clean equals to clean text VEC equals to TF-IDF dot transform clean. Predict equals to best model dot predict VEC equals to 0. Return predict. Function to predict sentiment for any new text message. It cleans, vectorizes, and predicts using the best model. Samples equal to I love this new feature. The service was awful and slow. It's okay, not too bad, but not great either. Test the model with example text and prints predicted sentiments for each. Step 13 is export clean dataset. df.to.csv clean sentiment dataset.csv index equal to false. Finally saves the clean dataset so it can be reused or shared later.